In this video, I'll explain extreme values of functions of two variables. A maximum or minimum values of f of x comma y are called as extreme values of the given function f of x comma y. It can have either maximum or minimum, then that is called as extremum. Now, to have extremum, the necessary condition is fx must be equal to 0 and fy must be equal to 0 at the given point a comma b. That means the function has extremum at the point a comma b if first partial derivative of f with respect to x and the first partial derivative of f with respect to y both must be equal to 0. Then this point is called as critical point of the given function f. This is just the necessary condition. This doesn't ensure that there always exists extremum. We have to further check with the sufficient condition. The sufficient condition says that fxx into fyy minus fxy square, if it is greater than 0, then only the extremum exists for the given function. After getting the critical points, you have to apply the sufficient condition, that is second partial derivative of f with respect to x into second partial derivative of f with respect to y minus fxy, first finding partial derivative of f with respect to x then with respect to y and its square. This expression should give you a positive quantity at that particular point a comma b. Then that point has maximum if fxx is less than 0. The second partial derivative of f with respect to x is less than 0 at that point, and minimum if fxx is greater than 0 at the point a comma b. So you can remember like this: for maximum it is lesser than and for minimum it is greater than. So this is the main condition for the given function, is to have extremum. This gives you the necessary condition. If this itself fails, then there is no maxima, no minima. But if this satisfies, you can't conclude that there exist maxima and minima. You have to further check it by applying this condition. It should be positive to have extremum. Now, one more thing to notice is that if fxx into fyy minus fxy whole square is less than 0, then f attains neither maximum nor minimum at the point a comma b. Then such point is called as saddle point, where this expression, if it gives you negative value, then no maxima, no minima at that particular point, it is a saddle point. In case if this expression gives you 0, so in this case it is always doubtful. You need to have the further investigation for giving the conclusion. Let us understand this by solving one problem. Find the extreme values of the function f of x comma y equal to, this is the given function. So to have extreme values for any function, the necessary condition is fx and fy must be equal to 0. So let us find out the first partial derivative of this function with respect to x. While differentiating partially with respect to x, keep y constant. So derivative of x cube is 3x square plus 3y square is constant. Derivative of x is 1 minus derivative of 3x square is 6x. 3y square anyway constant, so derivative 0 plus 4 is a constant, derivative is 0. This is fx. And fy equal to partially differentiating f with respect to y, x is kept constant. So derivative of x cube is 0 plus 3x is constant. Derivative of y square is 2y minus 3x square, it is constant. So derivative is 0. 3y square is minus 3 into derivative of y square is 2y. So it is 6y plus derivative of 4 is 0. So fx, I got this value and fy is this. So fx must be equal to 0 and fy must be equal to 0 to have extremum for the given function. Therefore, equate them to 0. Fx equal to 0 implies 3x square plus 3y square minus 6x, which is equal to 0. And similarly, fy equal to 0 implies 6xy minus 6y equal to 0. So from this we get 6y into x minus 1 equal to 0. This implies x equal to 1 and y equal to 0. So here it is and so both conditions must satisfy at a time. Therefore, I got the value of x equal to 1 and y equal to 0 from the second condition. You have to substitute that in this first condition. So when y equal to 0, so let us find out what is the value of x here. So 3x square, this is 0 minus 6x equal to 0. So 3x common, x minus 2 equal to 0. So which gives x equal to 0 and x equal to 2. Therefore, you get for y equal to 0, there are 2 points 0, comma 0 and 2, comma 0. 0, comma 0, 2, comma 0. At these 2 points, fx equal to 0, fy equal to 0. There could be extremum. Now take another now x equal to 1. So when x equal to 1, let us see what happens here. 3 plus 3y square minus 6 equal to 0. Put x equal to 1 here. So you will get 3y square equal to 3. 3 minus 6 is minus 3. When it goes to the right hand side, it becomes 3. So this implies y square equal to 1, y equal to plus or minus 1. Therefore, now when x equal to 1, there are two possible values for y. They are 1 and minus 1. Hence, here you will get two more points. One is 1 comma 1 and 1 comma minus 1. Therefore, at 4 points, fx equal to 0 and fy equal to 0. So these 4 points are called as critical points. This is the necessary condition which satisfied now. Here there is a possibility of the given function having extremum at these points. Now you have to check for these points individually, that is one by one, whether maximum or minimum exists or is it a saddle point. Let us do that. Now, after getting the critical points, you have to check the condition fxx into fyy minus fxy square, is this greater than 0. So fx we have, find out fxx, partial differentiating fx with respect to x. So we will get 6x, y is constant, so this is 0, minus 6. fyy equal to partially differentiating fy with respect to y. So 6x minus 6. And fxy equal to partially differentiating fx with respect to y. So x is constant, this value 0. So it gives you 6y. This is also 0. Now by substituting here, I'll get 6x minus 6 into 6x minus 6, which is 6x minus 6 whole square, minus 6y whole square is nothing but 36y square. 6y whole square is 36y square. This is the expression fxx fyy minus fxy square. Now I have to check, is it positive for each and every point. So consider the point for 0, comma 0. Put x equal to 0, y equal to 0. So here I'll get minus 6 whole square, which is 36. Anyway, this is 0. So this is positive. 36 is positive. So this expression is greater than 0 for 0, comma 0. And you have to check the sign of fxx. Fxx is x equal to 0, fxx equal to minus 6, which is less than 0. So this is positive and fxx negative means this is a point of maximum. There exists maximum at this point. And what is the maximum value of the function? Put x equal to 0 and y equal to 0 in this function. So you will get this is 0 plus 0, 0. This is also 0. So 4. Maximum value of the function is 4. Consider the second point, that is 2 comma 0. For 2 comma 0, let us check, is this expression positive. So put x equal to 2, 6 to the 12 minus 6 is 6 square, minus this value y is 0 means it is 0. 6 square equal to 36, which is positive. Therefore you have to check the sign of fxx. Fxx is equal to, put x equal to 2, 6 to the 12 minus 6, which is 6, that is positive. Therefore, this quantity anyway positive. Fxx is also positive, means this is the point of minimum. So what is the minimum value of the function? Put x equal to 2 and y equal to 0 in the function. 2 cube is 8 plus, anyway this is 0. This is 2 square is 4. 4 3 is 12 minus 12. This is 0 plus 4. So this gives you 12 minus 12, that is 0. So minimum value of this function at 2 comma 0 is 0. Now consider the third point, 1 comma 1. For 1 comma 1, put x equal to 1. 6 minus 6 is 0, minus 36 into y is also 1. So which is minus 36. This is less than 0. Whenever you get this expression less than 0, therefore at this point there is no maxima, no minima. So this point is called as saddle point, because we got this expression itself negative. Hence for this point 1 comma 1, no maxima, no minima, such a point is called as saddle point. Now take the last one, 1 comma minus 1. For this point, put x equal to 1. This is anyway 0, minus 36 into minus 1 whole square, which is 1. So minus 36. Again this is negative. Therefore, no maxima and no minima at the point 1 comma minus 1. This point is also called as saddle point. This is how we find the extreme value of the functions of two variables. I hope you understood the concept. Thank you for watching.